Hi, today I have Stefania Leon, Director of Product at Databricks. Hi, Stefania.
Hi, Yusuf. Nice to be here.
I'm super happy to have her today. She will talk about the UC compute. And I know a lot of people have been asking questions about the evolution of the compute since we started rolling out UC. And Stefania is the right person. She will tell us the story and how it's evolving and tell us more about the latest features.
When we introduced Unity Catalog, we did that because everyone still wants to use data governance rules in order to protect an enterprise data. There's a lot of very sensitive data, such as PII data. There's many collaborators, so not everyone should see everything. So at Databricks, we need to make sure governance is always enforced, especially now that we have Unity Catalog. But back then, what we did have was Databricks SQL, which had something called table ACLs, where you could define grants on tables and views and so on. But we also wanted this to work for Spark workloads in Python and Scala, right? And we did have this cluster type high concurrency, which tried some of the work we did later on, but it ended up with a very, very limited API surface area. So why was that? So basically, there were two challenges if you want to have governance and Spark workloads in Python and Scala. So Spark does not really know about governance, right? So it was built as a single user, single application framework. Users run as root. So it's a shared JVM if you are multiple users. You share the JVM as well with the engine. You have privileged machine access. So it's not really an ideal environment to enforce governance where like I shouldn't read your data and you shouldn't read my data and so on. But of course, our customers, they're used to like sharing compute. So you can reduce the costs, you have better utilization. And also we as Databricks, we want to have like a scalable serverless platform, right? So ideally we can build that on shareable compute. So the challenge was like, how can we like securely share compute and enforce governance? So we did a couple of things, which is basically what you see on this slide. We started with what will be called the dedicated access mode, was initially called the single user access mode. So there we said, okay, in order to make sure data governance is always enforced, instead of sharing compute, we just have a single user on the cluster, right? So no one can read anyone else's data and so on. There was one problem. We didn't have fine-grained access control until like 15.4 LTS. So why was that? It's because when Spark processes a view or a table with RLS CM, like row filters, column masks, what Spark does, it like fetches all the tables, and with that, like all the underlying data, and then does the processing locally. So this would mean like I could just, if I would want to, just go and like read data I may not have been granted access to, right? If you have like some row level filters, like you shouldn't read the whole table. That's why we have them. So but then what we did in order to circumvent that is with DBR 15.4, we introduced fine-grained access control, where like all these queries that run over views or over tables with RLSCM run on like dedicated background compute, and only the results are streamed back to the Spark server. So that's what you get on dedicated access mode. You get the full unrestricted Spark API. You get full fine-grained access control from 15.4 onwards. And very recently, we also added the ability to share that cluster. Now, you can only share it within a group of users with the same permissions. So that's why the cluster is then dedicated to that group. So if you and I are on the cluster, let's say for the podcast collaboration, only data that the podcast collaboration group can read can actually be read on that cluster. Like I can't read my data, you can't read your other data, just to make sure we're in a kind of secure environment. Yeah, so that's dedicated access mode. But then we also wanted to do better. It's like, can we have a secure multi-user cluster where we have full data governance and we can run Spark workloads in Scala, Python, and so on. So we did that by kind of taking a step back and looking how we can get there. So how can we make sure that on Spark we can isolate user code, like that we don't share JVMs anymore across users and so on. So we did a couple of things. One was we used Spark Connect. Spark Connect basically introduced a decoupling between the Spark engine and the client application. So it goes through the Spark Connect protocol, which is based on the data frame API, and it really decouples the engine from the client. So you don't have like two separate JVMs for each client. Like each client has a JVM, or the server has its own JVM, so you don't have like dependency clashes anymore and things like that. But also you don't share the JVM anymore, so you don't see like the problem we had to use the filtering for fine-grained access control. You don't have that anymore now because as a user you can't access the engine. But that wasn't enough. So because if you and I want to share a cluster, I shouldn't read like what you fetched. You shouldn't read what I fetched. So we also had to isolate our client application, like the notebook, the job, so that those run like fully isolated with their own JVMs. And then there's other user codes such as UDFs, those running on executors, they're also fully isolated. So that's our standard access mode where you now can run fully isolated Spark workloads in Scala, in Python, in SQL. The API surface area is based on Spark Connect, which is the data frame API or dataset API for Scala. And this is also the foundation for our serverless compute. So you can basically share compute with full fine-grained access control without any additional cost.
And just something I wanted to circle back. If someone is using the dedicated access mode for development, please don't switch it to shared or standard and vice versa. So if you're using a mode, then keep it for dev and production. Else you may have a different behavior because some APIs doesn't work on dedicated access mode, and the opposite can be true as well.
Yeah, exactly. That's very important. Like stick to your architecture because the API is different. Yeah, definitely.
And I guess we have also with the new names, we have also new API like API UI for cluster creation.
Yeah, exactly. So today, in Databricks, if you're opted into the group cluster public preview, you can opt in at the workspace level. You already get the new UX where you see the dedicated access mode and the standard access mode. By default, the standard access mode is picked. This will become available as an opt-in in mid-February. So it comes with a simplification of the cluster creation UX. So that will be available as an opt-in in mid-February and then will become the default later in the year. So basically then every time you create a cluster through the UI, the default settings would be on standard clusters. We're also working on the API, but that's a bit further out.
Perfect. Thank you. Thank you so much, Stefania, for
Thank
all
you.
those insights.